we will practice here numerical expression with exponents. Um, so we are assuming knowing the rules for exponents. And let's then, for example, try to answer the following questions. So first, you are asked to write the radical uh, or write using exponents. Okay. So for example, we are given 1/√5. Okay, so we want to express this number using as a number with a power. Okay. So we know that square root is the we can write it as 5 power 1/2. So already we are using a power here. Okay. Then so this is so I will try here to remind some the rules, the corresponding rules we are using. So for example, we used here uh, this notation, NEM root of x. We said it's x power 1/n, and we know how, depending on the parity of n, what must be the what are the possibilities for x, either positive or any value of r. Okay, so then from here I want to write it as powers, so I will just use then equal. Yes, I have then, I can write it as 5 minus 1/2. And here I use the rule a power 1/a power n is a power minus n. N is not necessarily an integer. We said it can be a fraction. So here is how we are manipulating applying the law of exponents for the numerical expressions involving only numbers. What about this one? Square a third 30 a third root of 7 square. So here again it's 7 square 1/m 1/3. Sorry, so 3, which we can write also 7 2/3. Okay, so this is how we extended. If you remember, we extended the NEM. We defined n, m, xn, okay, or m here and n on the other side. We keep just the same pattern here, n. We said it's x power m/n. Okay. What else? For example, what if we were asked to compute the following? Yes, the same thing here. So it will be 5 power 3. So it will be 3/5. Okay, so we can do that. Now, for example, the second question is to evaluate. We are asked to evaluate the expression. Okay, here it is. We have the first one, for example, this radical. Okay, using the radical. So third root of -64. So we know that it is what? -64. This is the power here. N is odd, so it is well defined for negative value, and it is just 1/3. So I need just to write -64. I can write it as -4 power 3, everything power 3, and a whole 1/3. Okay, so here I can remind you with the formula n of x power n is just, we can write it as, so it's x depending, it's x if n is odd. Okay, and let's write it well. if n is odd, and it's the absolute value if n is even. Okay, keep this in mind. And now I can write it, then I can find the answer here. So it will be just -4. Yeah, great. What else? Now, what about this one? 1 over 16. So I remark that my n is 4 is an even number, so I need to have a positive number, otherwise it's not defined. What else? So we can write it 1 over 16, it's 2 power 4, everything power 4, so it will be absolute value of 1 over 2, which is 1 over 2. Okay. Uh, what else? What about this value now? Third minus 1 over 64. So again, it's an odd and is an odd, so I can have a negative number. I can write it minus 1 over 4 power 3. Um, so I can put everything, yes, power 3, everything power 3, and then take the power, which is minus 1 over 4. Okay. What, yeah, what if we have now this quantity to compute, to evaluate? 96. So here, yes, it's justified to get to have a negative number under this radical. I can regroup the radicals because each of them is just a power. We can see it as power, and it's minus 3 over 96, 1 over 5. Let's see if we can simplify. So minus 3 here, 96 is 3 times 32. 32 is 2 power 5. Okay, 1 over 5. Then I can simplify by 3 and can write minus 1 over 2, everything power 5, and everything power 5, which gives me minus 1 over 2, the answer. Okay. Let's give, here is the another question or kind of question. You are asked this time to use radicals. Use radicals. Okay. Use radicals to express those numbers. For example, 4 power 2 over 3. So we'll use this. Yes, will be cube of 4 square. Okay. Uh, um, third cube root of 16. What else? 11 minus 3 over 2. So, so I can see it as square root. Okay. So I can write it maybe one step before. We have 11 minus 3, everything 1 over 2. We can do that, which is square root. Okay, square root. Square root, we don't put the 2 here. It's not necessary. 11 minus 3. We can have here something. We have square root of 11 minus 1. Or yes, we can use negative. So this one, yes. So I can have then, instead keeping it like that, you can say it's 1 over 11 power 3. But then I can separate square root of 1 over square root of 11 power 3. Here, square root of 1, 1 is 1 square. I'm taking the square root, so absolute value of 1, which is 1. And here I can separate because I see that I have square root here. So I have 11 square and they have 11. So I can separate and say I have to take square root of 11 square and 11. Square root 11. So this one gives me 11, so which simplifies the expression. Now, what about this one? This expression, um, Yes. What about the two expression? Look at the difference. Minus 32, 2 over 5. Then we said it will be um, yes, we want to use radicals. So and yes, we will simplify if we can. So I can say, yes, it's fifth root of minus 32 to the power 2. Okay. Then here to the power 2, so I can, it's, yes, you can use it minus 1 square, 32 square. So here I'm using the formula EB, okay, square, power is A to N and B N, okay. Let's come back then and continue here. So we will have 1. Um, yes, now I have, okay, um, 32 is 2 power 5, everything 2. I can say it's 2 square and power 5 because why? Because I know that I have a power n equal a power n times m. So I can also say it's mn, which is a m power n. So this is what I'm using here. Why? Because I have 5, 5, so I can take away the root, okay? And get the answer will be 2 power 4, 2, which is 4. Now let's compare with the other expression here, this one, minus 32 and power 2 over 5, okay? Then this time, it's just I have minus, I have 2 power 5, 2 over 5. And here I can use just 5 times 2 over 5, which gives me then minus 4. Okay, so this is, yes, it's important to keep in mind this. Each time you have an nth root of xn, you have to pay attention, is it x or absolute value of x?